Alright, welcome. Let's solve the problems on Algebra 2, Quiz 12.2. So, we're going to use the calculator to solve these systems, right? It's going to make it go really fast. So we're going to go into the matrix menu, and we're going to edit matrix A, and we're going to ask for a 3 by 4. And so we're just going to kind of type in the coefficients here. 1, -3, that was a -2, -3, 6, 13, 1, 1y, -4z, -9, 2, 1, 1, 7. And then we're going to ask for the calculator to do RREF on this thing. And ask for RREF on matrix color, on names, matrix A. And then we see, okay, when we see this 1, 0, 0, 0, 1, 0, 0, 0, 1 pattern, that's a unique solution. So I'm going to say my answer is x equals 1, y equals 2, and z equals 3. Now, for number 2, we're going to do the same thing, except maybe this time I'll show you a little faster way. So we're going to just start by asking for RREF, and then we'll ask for a matrix out of F3. But not all the calculators have this possibility, so 1x, 3y, 2z equals 0. 2x, -1y, -3z equals 7. And then 1x, 2y, 1z equals 1. If I ask for it to do that, and I see that row of all zeros, that's going to be infinitely many solutions. So I'm going to say 1x minus 1z is equal to 3, and 1y plus 1z equals -1. So that's going to be x equals z plus 3, y equals -z minus 1, and z can be whatever it wants. It's a free variable. And so that's going to be how I'll write my infinitely many solutions. Okay, and then down here we've got Joe, who has borrowed a damaged calculator. Okay, and x and y would represent the first and second missing entries in the reduced matrix. So a value of x and y that would make the matrix have a unique solution. Okay, well, we know that this number here has to be a 1. And if, y could be really anything, but I'd say y equals, 4, because then my solution would be 2, 3, and 4. Okay. But really, x is 1, and y could be anything. So let x and y, okay, no solution would be 0 and 1. Okay, and technically, these would need to be zeros as well, but that would be getting into the linear algebra of the situation. But we're not going to do that. Here we've got another infinitely many solutions situation. So I'm going to say x minus a z equals 0 and y plus 2z equals 0. So it would be x equals z and y equals -2z, and z can be whatever it wants because it's a free variable. So that would be my infinitely many solutions. And then if this is the augmented matrix, write the system. That'd be 1x plus 4y minus 7z equals 0. 2x minus 5y minus 8z equals 0, and then 3x minus 6y minus 9z equals 0. It said write the system of equations and don't solve it, but so I'm just going to stop there. That's all for Form A. Let's do Form B now. All right, find all the solutions. So I'm going to go and I'm going to ask for RREF of this 3 by 4. I'm going to type in 1, 3, 2, 7, 2, -1, 3, 7, 1, 2, 1, 6. Have it reduced, got myself a unique solution, 4, 1, 0. Okay, so I'm going to say x equals 4, y equals 1, z equals 0. Okay. And then I'm going to find all solutions to this system of equations, and I'm going to do the same thing, ask for RREF, bring in a 3 by 4 matrix, 1x, -3y, positive 6z equals -10, 1x plus 1y minus 4z equals 8, 2x plus 1y plus 1z equals 5. Have it reduce, and we've got another unique solution. I don't think that was supposed to happen, but I got x equals 2, y equals 2, z equals -1. And then this one, okay, is talking about the broken calculator. If this is going to have no solution, then I know it's 0, 0, 0, 1. 0 equals 1. So I'm going to say x equals 0, y equals 1. And if it's going to be a unique solution, we'd have x equaling 1, because then we'd have that 1, 0, 0, 0, 1, 0, 0, 0, 1 pattern. And then y could be like anything you wanted. Like, again, form A, I said it was 4, so I'll stick with that. And the solution, the unique solution would be x equals 2, y equals 3, z equals 4. All right. Now over here, we've got infinitely many solutions, right? We know that because of the row of all zeros. So I'm going to say x plus 3z equals 0, and y minus 4z is equal to 0. Kind of solve for x and y out of those. And then z can be whatever it wants. It's a free variable.
Hi, Michelle.
Hey. And then down here, the last one, we've got an augmented matrix that represents a system, so that'd be 9x plus 6y minus 3z equals 0. Each row corresponds to an equation. We're just going to kind of copy them in. Okay, and there we go. We got ourselves a system. It didn't ask us to solve it, so we're just going to stop there. That's going to be all for this video. Thanks for watching.